For this question, trial and error or trial and improvement's out the window. We've got to have like a logical approach to it, because even if you manage to find some values of t, how do you know you found them all? It's actually going to take a long, long time if you're trying every single permutation. So we want to avoid that, basically. We need to do this algebraically. I'm going to say that the larger regions on the outside are A, B, and C, and then the smaller ones are D, E, and F. And we have to use the numbers from 1 to 7. So if I add these up and the number 6, then that must equal the sum from 1 to 7. You can sum 1 to 7 with the formula half times 7 times 8. That's a half n plus 1. Formula for the nth term of a triangle number. Of course, you can just add them by hand if you prefer. That's going to be a half of 8 is 4. 4 times 7 is 28, which means that A plus B plus C plus D plus E plus F is going to equal 22. That's quite a nice result to have. I say nice result, I actually mean an essential result. So in fact, let's put a box around it. Okay, there's other things we can write down. When I did it, I said things like A plus D plus F must equal B plus D plus E and got some results from that. But a more crucial one, actually, because we're interested in the total in the circles, is to start adding each of the circles. So A plus D plus 6 plus F is going to equal T. And similarly, B plus D plus 6 plus E is equal to T for the top circle. And then C plus E plus 6 plus F is also equal to T. So if I add all of these up, and there's going to be a reason why we do this, then I'm going to get A plus B plus C plus D plus E plus F. And then I'm going to get an extra D, an extra E, and an extra F. D, E, and F. And then 18. And that is going to equal 3 times the total. The reason I've set this up like that is that this, remember, is 22. So I can rearrange this. This implies that D plus E plus F plus 40 is equal to 3t. And now we can use this relationship to get some conditions on t. Because the minimum value of D plus E plus F is going to be 6 if we have 1, 2, and 3. So that means that 3t has to be greater or equal to 46, which means when we divide through by 3, t is going to be greater or equal to 15 and a third, which means because it's a whole number, t is greater or equal to 16. Let's look at the maximum value of D plus E plus F. That's going to be when we use 7 and 5 and 4. Remember, we can't use 6, we've already used it. So that's 16. And what that means is that 3t has to be less than or equal to 40 plus 16, 56. So t is less than or equal to 3's into 56. Go once, then 8 remainder 2, so 18 and 2/3, therefore t is less than or equal to 18, which means overall there are only going to be 3 possible values for t, 16, 17, or 18. We've not and this is great, isn't it? Because we've not actually found out whether they're possible. We've just shown that if it's possible, because we're not done, if it's possible, then the only way it's possible is for 16 and 17 and 18 to be the values of t. Okay, it's time to consider each of these cases separately. So first up, t equals 16. That means that a plus d plus f must equal 10. Right, it's time to consider each of these three cases separately. So first of all, I'm going to take a look at t equals 16. Then what I'm going to find is that we get 3t is 48 minus 40, so d plus e plus f has to equal 8. And there might be more than one way to do this. I just need to find if it's possible or not. So we could maybe try 1, 2, and 5. 1, 2, 5. And then we need the total to be 16. So here I get 7 plus 5, that could be 4. Here I get 9, so that could be 7. And here I get 13, so that could be 3. So it's possible. A solution is possible. That's all we need to do. So how about t equals 17? Then in this case, 3t is going to be 51 minus 40. D plus e plus f is going to equal 11. Now the issue with this, if you look at this circle, is that a plus d plus f plus 6 is going to have to equal 17, which means a plus d plus f is also going to have to equal 11. And therefore a equals e, which is not possible. So in fact, although t equals 17 satisfied the earlier conditions, we can't actually make it work. No solution. That leaves us with t equals 18. So now d plus e plus f is going to be, I think I just have to add an extra 3 on to get 14. Let's just double check. So um, I'm going to have 54 here, minus 40, yeah, 14. Okay, and perhaps we just, this is quite a large number now. Perhaps I just try something else. So I don't know, 2 plus 5 plus 7. Could go with that. Remember the total is 18. So actually that's not going to work because I've already got a total of 18 here. Let's cancel that. What about 3 plus, I can't use 6, 3 plus 4 plus 7. Okay, now I've got 13, I've got 17, I can put 1 here. Here I've got 16, so I can put a 5 here. And here I've got 13. Sorry, does that make sense? 9, 16, sorry, it was a 2 there. And then a 5 here. So this is possible. And I do think at this point, like, just trying some different numbers out to add to 14, like you can see the first time it didn't work. That's probably the quickest way to go. The solution is possible. Therefore, t equals 16 and 18. Let's just remind ourselves what the original question was. What values of t are possible? Give rise to solutions or other values do not. And we've shown that with absolute certainty. So that is a really solid way to do this question, and I would advise you to try and use like the total, get an equation involving the total, and try and get it down to a certain values. If you could avoid this method actually of finding the total using this approach, and you'd have to construct some other conditions, such as the fact that a plus d plus f equals d plus b plus e. So, for example, these two must equal one another. And then you could systematically like try different values out. You could, for example, put 7 here and then see, what results from that by trying different values of D and F and so on. You could then try 7 on the inside. It would work. It's just not quite as careful and, to be honest, simple as getting something in terms of the total. Okay, fine. You've got to say, look, well done. This is a tough problem, especially to show it with the rigor that I have here. Well done on your efforts. Cheers.